All right. So last time we talked about size conversion. Well, we did our shortcut stuff, and then we talked about size conversion stuff. So we have an understanding of, how data is usually described. So if you think about what we've talked about in terms of our supplementary information so far in the course, we've talked about different ways of counting numbers, right? Different ways of representing values with different bases, because these are allows us to speak the different languages that a computer might be speaking, binary, decimal, octal, hexadecimal, so forth. And then we've also now talked about the different ways that data size is expressed. So just like in real life, you can say something weighs so many pounds, or something weighs so many kilograms, or something weighs so many ounces, things like that. These all mean the same thing. They're just different ways of expressing the same thing. So the same thing is true here with our size conversion stuff. And I think it's important for technologists to understand those differences and appreciate those differences, and also listen to the nuance. I think I mentioned last class, like if you look at the internet providers and you look at what they're offering and you watch their commercials, they'll say something like 200 meg internet. So the commercial might say 200 meg internet. So what does this mean? Well, to the consumer, what are they really comparing this to? So if we're saying something like a Spectrum in this area, so Spectrum cable modem is offering 200 meg internet. What does this really mean? Well, they really want you to compare this to AT&T's, up to 24. A lot of times they'll compare it differently, I guess, but let's just say meg. 24 meg internet, something like that. So when you're looking at it just like that, or even if we assume that this guy is megabits per second, so AT&T advertises theirs like this, Spectrum advertises theirs like this. Any way you cut it, this 200 is a lot bigger than the 200 is a lot bigger than the 24 from AT&T. All right, and we'll talk about those differences here in a minute. Again, remember, we're kind of adding in supplementary information because not everybody in the program has a background in computer science. The main networking content you're going to be getting is from the networking theory content that you're going to be getting is from the book and the homework stuff from Blackboard. But hopefully I'm going to be adding some stuff that all of you haven't heard of before. All right, so in any case, to the average consumer, we look at these two when we're deciding to buy either internet from Spectrum or internet from AT&T, and it looks like it's a pretty easy choice between these two, just because of the number. And then we operate off of cost, right? We operate off of how much is it going to cost us to get AT&T versus Spectrum, and what are we going to, what are we really going to use the internet for? All right, but we want to understand, what is this 200 meg internet stuff for? Well, first thing we want to consider is, what do we use the internet for? So, I'll get us started. So we might say web browsing, right? Email, video streaming, video games, maybe file downloads, and let's just call it something like online chat. All right, so let's just kind of leave it at that as our range of things we might use the internet for. And actually, let's say file up, downloads, uploads. All right. So when you are web browsing, it's the size of the web page. So what we're talking about right now is the size of data. It's the size of the web page that dictates how long that page, well, the size of the web page along with what the speed of your internet connection is, along with the ability of the web server to serve that page. We'll talk more about that here in a few minutes. All those things put together says how long the page will take to load. All right, so as a human being, we want all of these things to feel fast, right? Anything we're doing, we want it to feel fast. And once something is fast enough, we might not be able to discern the difference between fast and ultra fast or something like that. So with that in mind, let's just make up a number. Let's say that a website, let's say the size of a web page is usually less than 5 megabytes, something like that. All right. Email, when you're downloading email, most emails are very tiny, right? So we can say less than 1 megabyte. Video streaming. Okay, well, now this guy becomes interesting. That's going to be on a, we'll talk about that more on a different slide. Video games. I'm going to come back to this here in a second. File uploads, downloads. Typically, if we're downloading a file off the internet, you're kind of downloading like an installer or something like that. At that point, you're probably talking in the 50 megabyte plus, range up to, a gigabyte, 2 gigabytes, 3 gigabytes, that kind of stuff. Online chat is going to be similar to our video games here. So now one thing that we run into. So, I'm sure some of you in here are gamers. So actually, let's. How many of you are play video games? Anybody in here a big gamer? Wants to share with us? Nobody in here plays online games. Nothing. Just 100%.
I play, sir.
Okay. What's your favorite game?
Call of Duty, FIFA.
All right, Call of Duty and FIFA. Okay, we're going to use Call of Duty in our example here. All right, so because FIFA is like unless you're playing online, but they're going to be similar things actually. So let's use Call of Duty as our example for our video games. Now, when you're and if you've never played Call of Duty is like a first-person shooter war type game where you're a dude running around with a gun trying to kill players from the other team, and you're kind of in an urban setting, or there's actually a bunch of different kinds of settings you can be in with the maps, and you can hide behind stuff and try to catch them by surprise, yada, 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 stuff like that. But you basically have a bunch of players running around on the in a single world. I think it's 5v5, but whatever, different games have kind of different team sizes, but similar to that. So let's say you have 10 simultaneous players running around on the same kind of fixed size map, and trying to kill each other. That's it's a very calm, Zen type of video game, I guess you would say. So we might say, okay, well, how much data does that really take? Now, and this is where the some confusion might come in terms of network application. So in this case, we're using this video game as an example of a network application because the idea is that you're playing online with other people. All right. All right. So Now, if you look at a modern video game like Call of Duty, which would be considered a AAA video game, it's made by some, Blizzard Activision that, well, now, I don't know if you saw the news yesterday, Microsoft bought them. So technically it's made by Microsoft now. Interesting news. But made by a big company with a lot of money behind it. Zillion developers worked on this game, all this stuff. So we would say a game like Call of Duty has very high-end graphics. We would say that this guy, it's one of the main esports. So we would say esport compatible. And what that really means is performance is maintainable and low latency. And we'll talk about that. All right, because people are competing against each other in this game for money. All right, and that's a whole nother story. Esports has kind of become a big deal. So esports has become a big deal at a lot of universities. In fact, Concordia has, we now have an esports team, and we host their arena in the computer science department. So now we have a coach that goes out and recruits college students specifically for playing video games. And one of our big teams is Call of Duty. Now, the funny thing with that, now, I mean, I'm a lifetime gamer as well. I used to be big into World of Warcraft, and before that, EverQuest. I don't play those anymore, but now I do a lot of stuff with virtual reality. My wife's just making cereal, so just that's what the noise is. No problem. So in any case, now I do a lot of VR stuff. And that's going to be a very similar argument to what we're going to be talking about here in terms of video games as a network application. But when we look at these games, they look amazing on the screen. You got all these explosions and high definition graphics, and it's easy for a typical consumer to immediately look at something like that and make the assumption that must be taking up a lot of network data. It's easy for us to think that. But now we need to separate. So we might say, how much network data does this take? And we need to separate client side from server side when we discuss these types of things. All right, because we really have two different things here. We have client side is, what does the game look like? Server side is the communication between game clients to ensure players are at the correct position on the client screen, and to emulate the game tactics. All right, so all those high definition graphics and explosions and things like that, those are all taking part just on your computer, using your computer's high-end graphics card and your computer's processor and all that stuff. It's not using any of your network bandwidth to do that. All right, so really, when it doesn't matter how complex, interesting looking that game looks, ultimately what's happening under the hood is something very similar to what we talk about with like online chat. We're having text-based data move back and forth, and in some cases voice chat data, but that's probably happening on a different channel. So for instance, those of you who play Call of Duty, you are probably you're probably also doing voice chat with your other teammates or something like that, or at least that's not an uncommon thing to do. And some people do voice chat in video games through the video game's built-in client. A lot of other people use third-party clients for their voice chat, so it's actually completely separate from the video game itself. But regardless, it's still using network bandwidth to manage that voice chat. Okay, but that's a whole different channel than all those graphics and things like that. So it really doesn't matter how graphically intense a video game is. That doesn't dictate the amount of network bandwidth that it's going to take during playtime. Now, when you have a game update, so you open up Call of Duty, or my experience like World of Warcraft, when they release a new patch or something like that, well, that might take 20 minutes to download because it might be 5 or 6 gigabytes in size or something like that. But that's an upfront thing that's not reliant on your real-time communication with other players and stuff. That's just you going and making breakfast or lunch or whatever while your game finishes finishes patching, that type of thing. Okay, so that's a different use case for the game, and that gets back to our thing here where we're dealing with like file downloads, uploads type stuff. All right, but in terms of real-time playing of the game, when you're playing your Call of Duty game, the actual network usage is going to be much more like online chat. Okay, now you might be sending information very, very often. All right, but the size of that information is not that big. All right, so you don't necessarily need a super fast / good internet connection. We're going to talk about what that means here in a second. All right, so client side for a video game, this is what's actually taking up the most computing power, but that's all on your computer. All right, so now we come down to what makes an internet connection good. All right. So one thing we might say is there a such thing as the best internet connection? What do you think? Is there a best internet connection that you can get?
Yes.
Okay. Tell me about it.
Military connections where we need a high frequency internet connection to communicate between the soldiers and the headquarters. And in nowadays, the space arena that is required high internet connection to communicate with high frequency with the long distance.
Low latency.
Okay, so somebody just said low latency. So really, we measure internet with 3 different things. Okay, we measure internet in terms of latency, download speed, upload speed. Okay, now we just talked about online video game, and we said that really a game like Call of Duty is kind of geared towards esports. It's one of the most popular teams. I think we have 2 Call of Duty teams at Concordia. What I was about to say with our esports team, which is kind of a funny thing, for our student athletes at Concordia, one of the perks that a student athlete gets when they're an undergraduate student at Concordia is they don't have to take one of the health and wellness classes, part of a liberal arts education at Concordia. We're a liberal arts school, so you have to have a very well-rounded undergrad education. I'm not necessarily sure I'm in favor of something like that. I would just as soon say, hey, you want to be a computer scientist? Let's just take a whole bunch of computer science or stuff very closely related to computer science. But at the same time, we don't want to be, graduating idiots, I guess. So, you have to take English and psychology and sociology and all these other things that are perfectly reasonable classes in their own rights, but I'm not sure how much a computer scientist needs some of those skills. They would probably benefit from more computer science. But that's not how liberal arts education works. So, you know, at Concordia, you have a core group of classes that you take that are across the board types of different backgrounds. And one of those is health and wellness. You have to take like a sport. There's like a hiking class or a bowling class. And, you know, that's kind of ridiculous that you're paying college tuition to go bowling. But, you know, regardless, everybody has to take that class. Well, if you're an athlete at Concordia, you do not have to take, that's waived. You don't have to take the health and wellness class. So what's funny is the esports athletes also don't have to take the health and wellness class. You know, and most modern folks might say that, okay, when you say that playing video games is a sport, they kind of, you know, cringe at it or something like that. But, you know, it definitely takes, you know, a high level of skill for these video games. So I don't want to take away that aspect of it, but it's certainly not a exercise-based sport. It's much more strategy and fast twitch muscles, I guess, things like that. But it is kind of funny that the esports players don't have to take the exercise class. So I don't know, I find that kind of interesting. Another game that I'm big into these days is, you know, I guess as I've gotten older, I've gotten significantly worse at fast video games. So like I've played Call of Duty several times with students, and yeah, I'm terrible at it. It just things are happening way too quickly on the screen. They usually have to kill me, so I come back to life and I get a fresh gun because I'm not good enough to go and find the reloads and stuff. But I play Hearthstone, so I play a lot of those online like strategy card games, Magic the Gathering, those kind of things that I can leverage my brain for, and that's a little bit more my speed. And this last year, I haven't been doing it much lately, but I was playing professional Hearthstone tournaments, so I was helping train the esports Hearthstone players. So if any of you play any online card strategy games like that, you know, contact me. We can play sometime. I also play a lot of Dungeons and Dragons stuff in VR. There's a game in VR called Demio, which is fascinating. If any of you, I'm not sure, is Dungeons and Dragons like tabletop role-playing stuff? Is that a thing in India? Like, do you know, was that something that people like commonly played in India either more recently, or for here it was really popular like in the 80s? Now it's kind of been supplanted by video games, but we still have a population of people here that are into the kind of the old style games where you get 4 or 5 people sitting around a table, and it's almost like a board game type thing, but you have your player, you're moving around and you're attacking one of the players is the dungeon master, and he says what monsters are going to attack and where they are and stuff like that. Is that at all part of culture in India, that game, or is that just an American thing?
No,
No, not really.
maybe, yeah, we are into different kind of sports, and mostly we play on the ground, not necessarily on the virtual game.
Okay. Yeah. So, but anyways, I was big into Dungeons and Dragons when I was younger because we didn't have video games. But so like games like World of Warcraft and those things, they try to emulate the idea of Dungeons and Dragons with hit points and stuff like that. Well, one thing I'm fascinated by virtual reality. So once some of you get on campus, if you are interested in VR, we have a bunch of headsets, and we're doing a lot of development for VR. But there's a game in VR, if you wanted to look it up. It's called Demio, Demeo, and it effectively captures old school tabletop Dungeons and Dragons in VR. So it's a game, but it's strategy based. You actually reach down, you pick your little character up, and you move him to one of the squares that he's allowed to move to, and then you you decide what he's going to do. Is he going to attack a monster? Is he going to cast a spell? Is he going to heal somebody? You know, whatever it is. And it's amazing how such a modern technology like virtual reality captures such an old school way of playing a game. So it's it's just kind of this killer application for that geeky Dungeons and Dragons-y crowd. So you're playing old school games with the newest school technology. Kind of a fascinating thing. But once you get on campus, certainly let me know if you're interested in any virtual reality stuff. We have a bunch of headsets. We can set you up for you to try it, mess around with stuff, things like that. And then if it's something you're very interested in, we can certainly get you involved. That's one thing that a lot of students don't take advantage of in school is they don't take advantage of the stuff that's happening outside of the classroom. And we have a lot of different cool toys. Same thing, 3D printing. If you're into that kind of stuff, we have the biggest 3D printer based makerspace in the state of Wisconsin at the school, and computer science runs that. So if you're a CS student, you get free access to all the plastic and stuff. So we want you to come in and start inventing crap and printing it off on the 3D printers. It's another fascinating thing. So even if you've never messed with that stuff, that's another thing. Take advantage of that. Reach out. I can get you connected with Blade. He's the manager of the makerspace. He's got his master's in IT and his master's in computer science from Concordia, and now he's one of our professors. So he teaches in the department undergrad classes. Just started working on his PhD at Marquette, but I can get you, he's a Chinese guy. I can get you connected with him, and you can mess around with 3D printers and stuff. So we really want to get you exposed to as many different technologies as possible. And we have a lot of the latest, greatest, coolest stuff, but you got to kind of take that step on your own to decide to get involved. So if you are interested in playing around with those other technologies, things that are outside of, let's say, the boring classroom, reach out to me and I can get you in touch with the right person, because we want students to be taking advantage of that stuff. So it's neat. But even with this VR game Demio that I was talking about, it's the same kind of thing as this Call of Duty. You have what's happening visually for you, and that's all happening on your computer using your graphics card. In my case, on my VR headset, using either the built-in graphics thing on like a Quest 2, which is a standalone headset, or using, if I'm doing PC-based virtual reality, using the, honking, that's kind of the highest use for graphics cards is VR. You got to have the latest, greatest, $2,000 graphics card to drive the highest end PC VR, so people don't get motion sickness by the screen refresh rate dropping too low. But in any case, all that stuff is happening on the client side. It doesn't have anything to do with the network. Okay, that server side, that's the network piece where we're communicating between multiple clients. So when I pick up my dude in Demio and I move him to Square X, that gets distributed to all the other people playing the game with me, so that they see my guy on their screen move to Square X. Okay, but that my guy moving to Square X is all happening on their client. All they got is like a little piece of paper type thing that says, move dude 3 to Square X, something like that. And then the client made that graphically happen. So it's not taking up that much bandwidth. Okay, but when we talk about what makes an internet connection good, we really need to measure it in 3 different ways. All right, so latency, this is a big deal for gamers. All right, especially, and this would be a good difference we can use between like a Call of Duty and a Demio, right? If I'm playing this tabletop Dungeons and Dragons type game with some of my friends in VR, latency is less of a huge deal, right? Because when nothing's happening in super real time. You don't want to have these huge delays, but when I pick up the guy on my client and I move him to a different square, how instantaneously that happens on the other player's clients is less important, as long as it happens relatively quickly. So so everybody feels like their game is running at full speed. Okay, but a game like Call of Duty is a competitive, like I said, it's an esport type game where that latency, the speed at which that communication happens between clients, whether it's happening in what's called peer-to-peer. So these are things where I'm going to start, connecting to some of the stuff that you're going to end up reading about in the homework assignment. So if it's peer-to-peer, that means that your game client is talking directly to another game client, as opposed to a client server model where your game client talks to a server and the server then distributes it out to the game clients. In any case, however they're accomplishing that in a particular video game, what's important in this argument is that, with a game like Call of Duty, which is a competitive type game, the expectation is movements and any sort of actions that occur in the game must be distributed to the other players who are playing the game, and they might be in different countries and stuff like that. It has to be distributed as close to instantaneously as possible. Otherwise, you might have a player who has an unfair advantage or an unfair disadvantage if they're on a crappy network connection. Okay, so to a Call of Duty player, they would much rather, if they're paying for internet, they would much rather pay for really low latency internet that maybe has a lower download or upload speed than to pay for a really fast download speed with middle of the road latency. Okay, all of our modern internet connections have reasonable latency for the general use of the internet. Okay, but playing Call of Duty competitively is not necessarily the general use of the internet. So those folks who are actual big time Call of Duty users, and they really want, to, whether they're doing it professionally for money or they just are take it seriously and really want to be competitive, they want the lowest latency internet connection they can possibly get. So to them, that's what makes a good internet connection. Okay, similarly, most of our consumer internet is asynchronous internet, which means that download speed is faster than upload speed. Business internet is synchronous internet. Download and upload are the same speed. Really, we could probably say costs much more. All right, so all of us, presumably, I mean, I guess one of you might have, their situation might be different, but a majority of us at the very least have consumer-based internet. We're buying our internet from Spectrum or AT&T, or, in many cases, with poor students, you're stealing internet from your neighbor, or, somebody in your building has Wi-Fi, and you're giving them $3 a month for a connection, whatever it is. But you're certainly not on business internet is the punchline there. But we have consumer-based internet, which is asynchronous. Why do you think that a company like Spectrum or AT&T sells their internet for consumers as asynchronous internet? Why do you think that they make the download way faster than the upload? What are they trying to accomplish there? And I'm listening. I'm just going to refill my coffee. So go ahead. Somebody give me a good answer. We got nothing? You got it. All right, go ahead.
Yeah, because business users require dedicated servers.
Okay, tell me about the server thing.
because they need to get connected all the time.
All right, so if we kind of draw a picture here and look at what does the internet actually look like? So the internet is a client server model at the high level. Okay. Now, I'm going to draw two lines here. Where's my lines? Just so you guys know, you're in for a real treat here. I've won awards for my my keynote artwork. This is high-end stuff. One of them went for auction a couple weeks ago for millions of dollars. My skill with keynote is just amazing.
Yeah.
You're buying that? See, I can probably still convince my mom that that's a true statement. So we have our client server. So the client in this case, this is your house, right? This is you. So that's home. All right. Using some sort of client software. Now, typically when we're talking about, I'm going to be amending this picture as we go further along, but when we're talking about the client from a consumer-based internet, we're talking about, we are talking about our personal computer, but more importantly, we're talking about the specific application that we're running inside of our computer. So in our example right now, we're talking about the Call of Duty software that's running on our computer. That is the client software that is currently speaking over the internet. Common uses, we might say, oh, well, I'm browsing the internet. So I'm going to open up Microsoft Edge, or I'm going to open up Chrome or Firefox or Safari, whatever your browser of choice is. That ends up being your client software, right? In that case. So that's the guy that's communicating over the internet. All right. Now, when we talk about the communication between a client and a server, the client, there's two channels. One is the upload channel, one is the download channel. All right. Now, if I am downloading, so I'll just add a statement here. The client's download speed is limited by the server's upload speed. All right. So it doesn't matter how awesome, how fast your home-based internet is. If you're buying 1 gigabit per second internet, which is kind of the fastest consumer internet that's available, you're a little limited on where you can get that, but let's just say that's the fastest that's available. And that translates to 128 megabytes per second internet. That's your download speed. In that situation, even though you have an internet connection capable of that for download speed, you could only download as fast as whoever you're connecting to is able to give it to you. So your download speed is limited by whoever you're connecting to's upload speed. Okay. So the client's download speed is limited by the server's upload speed. Now, I asked the question a few minutes ago, why is consumer-based internet sold as an asynchronous connection, where the download speed is significantly faster than the upload speed? Well, this is the reason why. The client, the server in this case, that's presumably a business or something like that, where they're going to be expected to have multiple clients connecting to them at the same time. So since those clients are downloading from them, their upload is being heavily used. So they need fast upload for a server. All right, so that's why business internet, which is what the server would likely have, is synchronous internet, where the download and upload are the same speed. Or you can even get situations where the upload is significantly faster because the server is not doing significant downloading, but that's probably not common because the server is doing downloading when the client is uploading information to them. All right. But the point is I asked the question, why does a company is our consumer internet asynchronous? It's because companies like AT&T and Spectrum do not want us to run servers out of our house. You know, our upload is fast enough to run small based servers hosting a game or something like that with 3 or 4 friends, no problem. But they don't want us to run, you know, production level network servers out of our house where we have, you know, thousands and thousands of users hitting our home IP address, expecting to be able to download things at high performance. All right, something like that. All right, so that's why they sell the internet differently in that case. So this is the model of the internet. And we'll come back to that. Go ahead.
Is it because of there is the cost associated to the internet service provider?
I mean, I think that the short answer is yes, but I don't think that's the only reason. I think data costs less today than it cost before. But certainly in the earlier days of internet connections, I think that data was a major thing. But I think it's also an opportunity. You know, is there really a difference between business internet and consumer internet? Really, probably the answer is no. Outside of a company like Spectrum or AT&T might expect a business to be more capable of paying a higher price, right? So, you know, what do? They go to a business and they say, okay, well, we're going to sell you your internet at 7 times what the consumer is paying for their internet. But here are the promises we're going to make you. We're going to say you have 99.9% uptime, yada, yada, yada. We're going to give you synchronous internet, same speed both ways, stuff like that. So really what they're doing is they're selling, let's call it roughly the same product with a higher level of service to a business because they feel the business is more capable of spending more money. And we see this outside of internet. So like where I see it like more modernly or more recently, let's say, in the VR world is, you know, you can buy a VR headset and the consumer headset is, I don't know, let's call it, I don't know, $500. Well, then they sell a business version of the headset. It's the same headset. It's the identical headset. But what they're doing is they're selling that for maybe like $1,300, you know, more than twice the price. But what they're doing is they're giving you, you know, like a hotline where if you need technical support, you can call them. They're giving you some official licensing stuff where you can legally do like public like renting of the headset and things like that. So you know, there's certain things that a consumer might take for granted. So for instance, the current poster boy for good VR is Facebook's Oculus Quest 2. It's by far the best headset, but it's also among the cheapest headsets, which is what I think makes it so good. You just have to get past your potential dislike of Facebook. But in any case, you know, I haven't looked at the small print, but I can almost promise you that inside of that user license, when you first set up the headset, you probably agree to something along the lines of this is for personal use And if you use this for commercial use, where like, maybe you open up a store where you're renting headsets out, somebody can come in, you collect some money, they can use it for an hour or something like that. You probably are not allowed to do that officially under the Oculus consumer license. In that case, you would probably need to buy their commercial headset, which comes with a commercial license that probably dictates how you are allowed to commercially profit or sell, use this headset. So that kind of gives you a pretty similar example to what we're dealing with here, where it's the same product, but the expectation of how it's going to be used is different, and therefore the core company, the company that's selling the product, says we're going to charge for this differently because we are legally for a different type of use, something along those lines. But I mean, certainly price is part of it, because when Spectrum or AT&T is selling consumer or business internet, and they're making the promise that, oh, you have 99.99% uptime. Now, I don't know if they're actually doing something differently behind the scenes. They're probably doing a little something differently, but it's entirely possible that their business and their consumer internet is absolutely identical, running off the same hardware. They're just making a promise to the business folks about the uptime, with the expectation that their internet should have that uptime across the board anyways. But by making that promise to the business, they're also obligated now to probably, refund the business some amount of money, or give them some level of compensation in the event that there is prolonged downtime, something like that. So it really is more of a economics, capitalism type thing, where businesses probably can afford more than a consumer can afford, or at the very least are more willing to pay a higher rate for stuff than a consumer, to make sure they're fully covered under certain licensing and that kind of stuff. All right. So most of us, if we go out and buy internet, we're buying asynchronous internet, where really our only limitation is that we can't conveniently run, let's say, business class servers out of our house. You can run little servers that your friends and stuff can hit for downloading stuff or something like that. So it's not like you cannot run a server. It's not like you can't be this guy with your consumer-based internet. You're just not going to be this guy at a large scale, because you don't have the upload, because your upload is their download speed. All right. So you just don't have the upload to serve a whole bunch of people at the same time. But you can get by with just a couple of users, but they don't want you to run commercial servers out of your house, which is fine. That makes sense for 99.9% of us, where we're really we're consumers of our internet, and our upload needs to be fast enough to be able to handle these things we've been talking about. So when we talk about a modern internet connection, here, in fact, let's actually see if we can get real numbers. So I'm going to say Spectrum, cable modem, speeds. Compare internet speed plans. We're going to have like a 200, a 400, a gigabit, something like that. Oh, look at that. Nailed it. All right. But they tell us the upload and download. They don't on there. Okay, yeah, so this gives us a decent breakdown. So the standard internet from, let's say, Spectrum sells their budget pleaser internet now is 200 megabits per second. It used to be something like 60, and then it was 100, then it was 200. So the cost of this is presumably getting less, or at the very least, the needs of the consumer does require that higher speed. And we'll talk about that with video streaming here in a few minutes. All right. But your upload or your download rather is 200 megabits, but your upload might be 10 megabits. All right. Well, what's 10 megabits? 10 megabits is 1.25 megabytes per second. Okay, that's your upload speed is 1.25 megabytes every second. Okay, now that's not super fast, but now we have to think about the that communication in a game like Call of Duty. The communication between your client, your Call of Duty client, and the server has a speed that is, well, when you think about what you need the speed to be, how much data are you actually transmitting within a 1 second period to the server to let all the other clients know where you are? Presumably, since it needs to be close to instantaneous for it to be kind of an esport, right? The amount of data it sends has to be very, very small so that the data can get there quickly, right? Even because you're still limited by the download speed of the client. So you can't give it huge amounts of data, relatively speaking, because it might take too long for it to download. And then all of a sudden the person on the screen has already died because the screen didn't upload fast enough. So presumably the amount of data that's being sent, see if we can see it on here. Call of Duty data packet size. No, this is for like download size. It's certainly going to be in the low kilobytes. All right, so they're claiming about 80 megabits per second of data per hour. So let's see if we can kind of do the math on that. So we have 80 divided by 60, so that gives us per minute. So that's 1.33 mega bits per second per minute. Now, when we talk about well, so let's now divide that by 8. So that's 0.16 megabytes per minute. I'm going to multiply that by 1,024. So that gets us kilobytes per minute. So then I'm going to divide that by 60. So that gets us 2.84 kilobytes every 1 second. Who knows how true this number is, but let's just operate as if it is true. All right, so 2.84 kilobytes every 1 second is the amount of data that's being shoved back and forth between Call of Duty clients. Now, presumably in a video game like Call of Duty, information is being sent and received multiple times within a second. Typically the refresh rate that's trying to be maintained in a game like that is 60 hertz. So that means 60 times in a second. So if I divide that by 60, so that's 0.047, so 0.05 kilobytes every frame. All right. So as your screen is uploading or is updating, the idea is that 60 times every single second, your monitor repaints the picture on your screen. So you should see any updates that have occurred, with the position of your competitors and things like that, up to 60 times per second. All right. So if we call this the ideal situation, 60 times a second, we're going to be sending some amount of data that uploads stuff. That data by our measurement here is going to fit into 0.05 kilobytes. All right, if you want to multiply that by 1024, that's 48.5 bytes per update, let's say. So every single time your game client sends a burst of data to update your guy's position and what he's done in the last 60th of a second, let's say if we're just maintaining 60 frames a second, he's sending out 48.5 bytes of information, right? Very tiny, relatively speaking, amount of data that the other game clients then need to use their computation power, like their CPU, to decide what does this mean, and then tell their graphics card to update the screen with this new information. All right, and that's happening very, very quickly. All right, so if we're trying to maintain 60 individual pictures every single second, that means that every 60th of a second, we need to be able to send 48.5 bytes of information. So we would call 48.5 bytes of information a relatively tiny amount of information for today's internet connections. That is why this guy right here is most important. Latency is the amount of time it takes for your signal to be sent from your computer to the server. All right, because just because your car can drive 200 miles an hour doesn't mean that if you're traversing neighborhood roads that you're going to be able to get it up to 200 miles an hour. You might not be able to fully take advantage of your maximum speed of your car if the roads aren't compatible with driving that speed. All right, so that's really what we're talking about here. So the latency, the connection between you and the server itself, that guy, that round trip time dictates how fast you might be able to, well, how often you can expect to get updates on that road. All right, so we want really low latency for gamers, so that presumably, since we are sending very small pieces of information every 1/60th of a second, that information will arrive at its destination very quickly, so that on the other end, a lot of times you might have single-digit millisecond latency. So even if we just call it, 15 millisecond latency, here we can Call of Duty good latency. So they're saying anything less than 100 milliseconds is considered acceptable. However, 20 to 40 milliseconds is optimal. So if we say 20 milliseconds is, we're going to call that good. You've kind of arrived with your internet connection for esports or something like that. That's the round trip time that it takes to get from your computer to the server and back. So presumably, you're updating the network is very, 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 very often. All right, so you have the capability of doing it more than once every 60th of a second. So your performance is solid. So the idea is that you should be getting updates as fast as possible, so that anything that happens in your game is because anything bad that happens is because of your human skill not being up to snuff, as opposed to your network connection hurting you. All right, so that makes some sense. So if we're talking about games, latency is what means good internet, especially when you consider that the cheapest internet you're going to be able to buy, by like our Spectrum thing, is 200 megabits per second. So 200 megabits per second, that is, so 200 divided by 8, that's 25 megabytes every second. And if I divide that by, oh, sorry, if I multiply that by 1024, that's kilobytes times 1024. That's bytes divided by 60. So your 200 megabit per second internet connection is capable of downloading 436,906 bytes every single second. And for Call of Duty, actually every single 60th of a second, not every second, every 60th of a second. All right. So Call of Duty needed to only send like 48 bytes a second. All right. So if I take that and I take 48 divided by all of this times 100, 0.01% of your internet connection is all that's being used by Call of Duty every 60th of a second if you're on the cheapest internet from Spectrum, from a download speed perspective. So starting to put it into perspective, okay, a video game like Call of Duty does not require a lot of download speed. In fact, it requires very little download speed. You know, if we extrapolate this out till we get to our 48, let's say. So let's go down to 20 megabytes per second. One. It's going to be so it's going to be 0.1. Oh. There we go. That'll cover it. So really, in terms of download speed, we only need 0.03 megabits per second internet. That's what we actually need, 0.03 megabits per second in order for us to have a fast enough download to deal with the amount of data that we would be receiving from a single client every 60th of a second. That's not very fast internet, okay? Or is it? 0.03 times 1024, that is 30.72 kilobits every 60th of a second. All right, so now this rolls back. If you know, most of you aren't going to remember the 90s, but when we still had dial-up modems in the 90s rather than cable modems and things like that, and we'll kind of talk about that here, you know, next class, the class after that, whenever I roll into it, you know, that's when you had a 28.8 kilobit per second modem, or a 33.6 kilobit per second modem, or 56K modems. Those are 56 kilobit per second modems. Well, now we're starting to get into that place where, you know, it is kind of equivalent. So those old dial-up modems were probably right in that ballpark of barely able to keep up with the amount of data that's being sent by Call of Duty today. And they certainly were not going to have the latency requirement to have competitive Call of Duty like we have today. All right, so all that kind of makes some sense when it comes to gaming and what makes good internet for gaming. So now let's talk about download speed and upload speed for video streaming. Because whether you're a gamer or not, you know, so some of you in here are gamers, some of you aren't, and some of you play games, you played like the, you know, little, you know, time waster games as opposed to competitive games. You know, I'm going to guess a very high percentage of you do video streaming stuff. You watch YouTube, you watch Netflix, you watch HBO Max, Prime Video, whatever. Anybody in here not do any video streaming and is willing to speak up and say something? Yeah, so to some level, we all take part in video streaming as an application on the internet. All right, so let's just assume we're watching Netflix. You know, by today, if we're watching a movie, and let's just say it's a hour-and-a-half movie, and we're going to look at this in terms of raw data. So let's say we're watching something that is standard high definition. So standard high definition, which is 1080p. Okay, so that's 1920 by 1080 resolution. So when we think about our TV screen, that's the number of pixels that the picture is going to be made up of, where a pixel is a little dot of light. All right. Well, so now we need to say, well, how much data is this? Well, we need to decide, well, what's the refresh rate of our TV signal? So let's go with refresh rate of HD movie. 24 frames per second. So we have 24 frames per second. Now we're going to say size of pixel for HD movie. This is going to come down to how many bits of is a pixel for the amount of colors it needs to be able to show. I want to see pixel data. Otherwise, I'll just make something up like 24 bit color. Bit color for HD movie. Okay, 24 bits total. 8-bit color is RGB, red, green, blue. So it's 8 bits for red, 8 bits for blue or green, and 8 bits for blue. So it's a total of 24 bits for each of those pixels. 24 bits of data for each pixel. All right, and we're doing 24 pictures per second. So how many total pixels do we have? We have 1920 by 1080. So that's 2 billion total pixels. So that's this number, total pixels, times 24 bits per pixel. So that gets us that number. Total bits per frame times 24 frames per second equals that number. All right, so that gets us 1,194,393,600 bits for every 1 second of HD video. Now, if we want to get that into, so let's divide that by 8, that's bytes. Let's divide that by 1,024, that's kilobytes. By 1,024, that's megabytes. That's 142.38 megabytes. 142.38 megabytes for 1 second of HD video. All right. So now for a 90-minute video, so 90-minute movie is equal to 142.38 megabytes per second times 60 per minute times 90 minutes. So times 60 times 90. Let's divide this by 1,024. So 750.8, let's just say. 750.8 gigabytes for a 90-minute HD movie. Okay, so 750.8 gigabytes is the total amount of raw data that would need to be sent over your internet connection for a 90-minute movie. Okay. $750.8. So what kind of internet connection does this require over 90 minutes? Well, 750.8 gigabytes. So if I divide that by 90, now I'm at 8.34 gigabytes per second. Sorry, by minute. So that's 8.34 gigabytes per minute. Divide that by 60, it's 0.14 per second. And what we can do is we can actually multiply that by 1,024. So that's 142 megabytes per second. Okay. So 142 megabytes per second is the what speed internet connection you would need to be able to download at to have a HD, 1080p movie. This isn't a 4K movie. This is only 1080p standard HD. Come to your computer screen in raw data. All right. Well, so let's see what kind of internet connection that's going to require. It's going to require more than a gigabit per second, because a gigabit per second gets you 128 megabytes per second. So 142 divided by 1,024 is a 1.3 gigabit per second. So requires a 1.3 gigabit per second internet connection. me multiply that by 8 first. Then I want to divide that by 1024. It's actually a 1.1. 1.1 gigabit per second internet connection. Okay, so super fast internet. Now, what's interesting here is when we look at this, we actually see that we have almost gotten to the point now where you can get the highest end consumer internet that could do this, that could actually stream in raw format a 1080p 90-minute movie. Well, any length movie. It can keep up with an HD raw video signal. All right. But for the purposes of this slide, we're going to say most, if not all, of our consumer internet can't do this. Okay. Yet, all of you told me that you watch Netflix or Prime Video or whatever, and presumably you've watched HD movies on there. How does that get accomplished? How are you able to watch an HD movie on your 200 megabits per second internet connection? Keep in mind that a 200 megabit per second internet connection divided by 8 is 25. A 200 megabit per second connection can only download 25 megabytes per second. 25 divided by 142. So we're only 17.6% of what we need for a raw HD video. Okay, so we don't even have 20% of the speed that we actually need for an HD movie yet. Most of you have watched in this last week, you've watched an HD movie or TV show or something like that, while other people in the house or the apartment are using the internet for other things. How is this accomplished? How do we pull this off? Especially when you consider that, you know, with Netflix and stuff, there are 4K movies now, which presumably is going to take up a lot more data than this. So how are you able to watch an HD movie on your computer from Netflix using your, reasonably priced consumer internet connection?
Is it through the host?
Say this again.
Is it through the host, like Netflix itself or the ISP?
Okay, well, so let's say yes. They're going to have to do something, right?
Yeah.
So somebody's going to have to do something because your internet connection's not going to do it. All right. Well, so what is the host likely doing?
Downgrading resolution.
Okay. Well, if they downgrade the resolution, now you're no longer getting HD, right? But you want HD. Remember, we're all humans. We're greedy, right?
Yeah.
We're just settling for the HD movie. We really want 4K, right? That's why, whenever I'm watching Netflix and, sometimes I'll just pick one of the 4K shows, even if I'm not as interested in it. I want 4K. It makes me feel like I spent good money on my TV. I have a 75-inch 4K TV in my living room and my bedroom, and so these are fancy schmancy expensive TVs. Why should I be watching normal HD on there? I might as well be watching a cartoon, right? Yeah, they're probably not going to be lowering the resolution because we want HD. So what else might they be doing?
Maybe when they send the data, they store it and the message goes through open and then 620, like saving the data every time.
Okay, so let's just create a slide here. How do they accomplish it on the host side? All right, so let me ask this question first. When you're watching Netflix at home, whether you're doing it on your computer, actually your computer is probably a bad example because that kind of hides it behind the browser, but let's say you're watching it on like a smart TV or a Roku or an Apple TV, something like that. There's like a Netflix app, right? Similarly, if we roll back and we think about normal cable television, whether you have AT&T or you have Spectrum or you have like DirecTV, Dish Network, something like that, they all come with a box, right? You got this extra piece of equipment that you plug into your wall, so the signal coming in from the wall goes into the back of the box, and the box connects to your TV. So we might say, well, what does that box do? Because that box has been around for a long time. What does the box actually accomplish? Anybody know? What is that box actually doing? Why did we need a box for cable TV?
To convert to required resolution.
Okay. So sort of in part that's true. That's part of the answer to our question here. What else?
To browse multiple channels.
Multiple channels, yeah. So when you had cable TV, maybe you're getting 50 channels. Well, all those channels are coming in over one cable, right? And that one cable has those 50 channels on it. You need that box to split those channels apart so that it can be delivered to the TV. And the box was running like the operating system that allowed you to choose between which channel you wanted to watch. And then the box presumably did some decoding, because if you felt that box would get hot, right? So the box had some sort of computer equipment type stuff inside of it. It would get hot. And that comes down to how do we accomplish this, whether we're dealing with old cable TV or we're dealing with our newer stuff where we have software running on our TVs, or TVs have kind of become computers in and of themselves. The host compresses the data so that a smaller amount of information actually is downloaded every second. And then the client must decompress that data in real time to show the full resolution image on the screen. All right, so what we're doing is we're marrying computation power with data transmission. We're saying, look, our internet speeds are only so fast, even though they've gotten a lot faster. Our internet speeds are only so fast. So in order to send a high definition movie over the internet, we really need to compress this image down. There's all sorts of different techniques for compression. We're not going to talk about the details of those techniques in here, but just we'll say, hey, there exists data compression algorithms that can take a large video and make it into a less large video. All right, now when we chop that up and we send it in 1/24 of a second chunks, that video can be, does take up less total data that needs to be transmitted. But then what we're doing is we're relying on the computation power of the client, the CPU, the whatever, so the computer on the client, to take that compressed data, decompress it so that it can be shown on the screen in its full resolution. All right, so the host compresses the data. So then we might ask, is this enough? say, no, we also buffer data. So you let your, so the Netflix client, takes, so a lot of times it feels like it happens instantaneously, but really it's several seconds up to, maybe 15, 20, 30 seconds, depending on the internet speed, it takes to start downloading the first bunch of your movie so that it's kind of already has like a head start for the decompression. You've already started downloading the movie and you're ahead, so you don't just have to keep up every 1/24th of a second. So between those two things, we're able to accomplish 1080p HD along with 4K video on multiple screens in a house at one time using our internet speeds. I'm going to kind of wrap up here in a second, but ultimately, when we go back and we look at Spectrum internet speeds, it's got to give us those options again. Oh, whatever. We had the two. Here we go. We had the 200, the 400, and the 1 gigabyte or 1 gigabit per second internet. Okay. Since our download speed is only as fast as whoever we're getting it from's upload speed, realistically, so this guy right here is 25 megabytes per second is our capability download speed every 1 second. 200 divided by 8, 200 megabits per second. To get it to bytes, we divide it by 8. That gets us 25 megabytes every second. We would say that 25 megabytes every second is probably plenty for any single application on the internet today, using data, because there's not that many sources on the internet right now that are going to give you data at a faster rate than 25 megabytes per second. So then you might ask the question, why buy faster internet? I'm going to kind of leave us with that question. I'm going to leave us with another question. Okay, so all of you should have received the email with this week's assignment that's due midnight on Sunday. I do see that most of you are now registered for the class, but there are still a couple that haven't quite been able to register. So I think we're probably getting close for those couple people. So actually, if you would do me a favor, if you are not registered for the class yet, can you shoot me an email just so I have that collection of people so I know exactly who I kind of need to keep track of grades separately for? And there's no pressure. I realize that we're at the mercy of immigration and visas and all that jazz, but just so I have for my records who's not registered yet, I'd appreciate it if you shoot me an email at michael.littman@cuw.edu, just so I have those couple of email addresses. But it looks like a majority of you are registered now, which is great. All right, questions, comments, concerns, bribes? Okie dokie. I will see everybody next Monday.